Okay, we're back here with number 4 on the practice exam. It deals with the discrete time Fourier transform. We've been given x of n, and we are asked to find x of e j omega. So we're going to do this by applying the properties of the discrete time Fourier transform, and the two we're going to be using, the first one is time shifting, and the second one is time reversal. So the shifting property has just the effect of multiplying the Fourier transform by e to the negative j omega n naught, where n naught is the shift, and the time reversal property has the effect of just adding a negative sign into the exponential. So if you had e j omega, you get e to the negative j omega, etc. So that's pretty straightforward. So what's not straightforward in this problem is the algebra, and that's kind of the game here. So we see I've written here that the relevant transform looks like this. We don't have un, we have a shifted version of it, so we know right away that we're going to deal with the time shift, which is why I have it up there. However, we don't have it in this form. So let's write x of n is equal to 1/3 minus n times u of minus n minus 2. Okay, so that looks good. The unit step function, that is. However, we need the same time shift in all areas of the function. So let's multiply by 1. And when I say by 1, I of course don't mean just 1. I mean 1/3 squared times 1/3 squared. That is 1. So 1/3 minus n times u of minus n minus 2. So that will give us 1/3, the denominator 1/3 squared, we can throw that up. 1/3 squared is 1/9. Since it's the denominator, it'll come up as just 9. And now we're going to move the term in the numerator to here. We're going to combine it, so we get 1/3 minus n plus 2. Hopefully you should see where we're going now. We can simplify this further. 9 times 1/3 minus n minus 2 times u minus n minus 2. Okay, now we have the same shift in all areas of the function, and we even have the same time reversal, so that looks uniform. So let's go ahead and apply the transform. We're going to do this in steps. So first we will use the property of the time shift, and we're going to ignore the reversal for now, so let's just pretend we don't have these negative signs here. So we would get 9 times e minus j, and n naught, the shift, is just going to be 2 times omega. So that covers the time shift, so that would be times whatever the Fourier transform was. So now the Fourier transform would normally be for a function that looks like this. Remember, it would normally be 1 over 1 minus a times e minus j omega. In our case, a is just 1/3, and we're accounting for the reversal. So normally we would have e to the minus j omega, but remember the reversal has the effect of taking the opposite there, so we can finally write the final answer as 1 minus a, which is 1/3, e, it would normally be e minus j omega, but it's e j omega because of the time reversal. And that is the final answer. Okay, B gives us y of n equal u n plus 2 minus u n minus 3. So let's graph this, what this looks like. We have this term is I'll do it explicitly, minus 2, it's a unit step shifted, minus 1, 1, 2, etc. So that's u of n plus 2, u of n minus 3, 1, 2, 3. It's a shifted unit step, so we get 3, etc. So if we subtract these, this is u of n minus 3, we will get minus 2 here, minus 1, this is y of n. So we go to our table of Fourier transforms, and I'm going to put the relevant transform up in a little window because my computer just died, so I no longer have the table in front of me, but it's going to map to e j omega, and we're taking it from this graph. Sine omega 2 plus 1/2 sine omega omega divided by 2. This is 1, 2. Okay, so C is C of n equals U of n plus 1 minus U of n minus 4. And if you go through the same procedure to find the graph as I did for B, you'll find that the graph 1, 2, 3 looks like this, which if you compare them to, you compare Zn to Y of n from B, you see that Z of n is actually just Y of n shifted by 1 to the right, which we write as Y of n minus 1, and we know from A this is a time shift, which is a property of the Fourier transform, and it's just going to multiply the Fourier transform by e of minus j omega n naught, where n naught is the shift. So we can say that the transform of z e j omega is equal to e minus j omega, and the shift is 1 times the transform of y, because z of n is just the shifted y. Okay, that's number 4.